Hi everyone, welcome back to Learn with Pooja. Today we are going to discuss about cosine similarity. Before going into the cosine similarity, in the previous section we discussed about like embeddings and how we have used embeddings in the rack system and all. So now we are going little bit in depth. It's like a what is the like a difference between two vectors or a distance between two vectors. What calculations we are doing. So the first one is a calculating distance between embeddings. The first and most important topic is the cosine similarity. Cosine similarity is a mathematical method used to measure how similar two vectors are based on the angle between them, not their magnitude. So, we can discuss in the step by step. Cosine similarity measures how similar two vectors are by comparing their direction rather than their magnitude. So it computes the cosine of the angle between two vectors in the high dimensional space. So here there is a sum of the diagram I will show you. So you can see this is like a x-axis and y-axis and a principal component 1 and component 2. Now we are finding a distance between the two vectors with the angle. So this is you can see this one and here, and it is giving like a angle between the two vectors. So this is called the vector distance between using a cosine similarity. Now we are going to the back. So what formulas we are using here? The first one we can go, if vector point is same direction, we can discuss about the directions now. If vector point in the same direction, the similarity equals to 1. So if vectors are orthogonal, it's like a similarity which is 0, it's unrelated, we can say. If vector point is opposite direction, similarity equals to -1, so it's not at all similar. So now cosine similarity formula is a cosine similarity a comma b is like a two vectors you can take, and a into b by mod a into mod b. So a into b is a dot product of vectors, and mod a is a magnitude norm of vector a, and mod b is like a magnitude norm of vector b. This is the simple formula which we are using for cosine similarity. So we can go in depth of dot product formula. So dot product a dot b is a into b equals to sum of ai bi. So n is like a number of directions. So for example, you can take 1536 for many embeddings. And next one is a element of vector a is the element of vector a, bi is the element of vector b, n is like a number of dimensions. So here is a simple example 1, 2, 3, and B is a 4, 5, 6, and dot product is 1 is a 4 times, and 2 into 1 into 4 plus 2 into 5 plus 3 into 6. So finally 4 plus 10 plus 18 equals to 32. So this is like a dot product. Now vector magnitude. So the magnitude of a vector represents the length of the vector in space. It calculates by squaring each element, summing them, and taking the square root. So this is like a next step. Vector magnitude, that is a norm. The magnitude of vector is mod a is the root of summation a square. So this normalization step ensures the similarity depends on the direction rather than the length. So example you can see, take a equals to a comma b, then mod a equal to square root of 3 square plus 4 square, it's a 9 plus 16, which is 25. Root of 25 is the 5. So this is the example. So why normalization matter here? Vector magnitude is used to normalize vectors so that similarity depends on direction rather than the length. Depends on the direction rather than the length. This ensures that cosine similarity measures the semantic similarity instead of vector size. So this is the main important for this is a way we are using a normalization. Now going to the next step. So you can we discussed already this. Now how we are combining this? Dot product measures the alignment between vectors, and vector magnitude is like a calculate the vector length, and cosine similarity is finally divides the alignment by the vector length. So this is the final formula. So now we are going to discuss about why this is important in AI. These formulas are fundamental to embedding semantic search, vector databases, fuzzy similarity search, and retrieval augmented generation, like different approaches. So we discussed already this diagram, how it is defining the angle between two vectors. So we have like a different calculations for checking the difference between vectors, like one is a cosine similarity, Euclidean distance, and Manhattan. So cosine similarity, how it will work in the RAG system. So cosine similarity is measures the angle between two vectors we discussed already rather than their absolute distance. In in embedding based system like retrieval augmented generation, cosine similarity is the most commonly used similarity matrix because it focus on semantic direction, like a semantic search. So you can see the first one is, yeah. So in embedding based system like retrieval augmented generation, cosine similarity is the most commonly used similarity matrix because it focuses on semantic direction rather than the vector magnitude. Why cosine similarity works well for RAG? User queries are typically short, while retrieved documents are often much longer. So, for example, reset password. That is a query. Document is like to reset your password, go to the account settings page and follow the password recovery instructions. All through the document vector will have a larger magnitude. Both vector points in the same semantic direction. So cosine similarly directly identify them as a highly related even though either length differ. Without normalization, longer documents might rank higher simply due to the magnitude, not semantic relevance. We already discussed about a cosine similarity formula. You can try yourself in your notebooks by using a Python or simple mathematical formulas. So we already discussed this value. One is a identical semantic direction, 0 is an unrelated vector, and -1 is the opposite meaning. So we can take a sample example calculation. So you can take is like a 1 2 3 and b is a 2 4 6. A dot product a dot b is a 1 into 2 plus 2 into 4 plus 3 into 6 is equal to 28. So magnitude is mod a is a root 14 and mod b is a root 56, and finally the result is 1, meaning that vector point is the same direction. So just give me a second. So we have other distance metrics all through cosine similarity is the standard metrics for embeddings. Other metrics also exist, we can discuss in the next video. Thank you. Have a nice day. Please keep follow for our next sessions are very important, and please subscribe my channel to get a more information in AML. Thank you.